Hi, so we're going to begin Chapter 9. In Chapter 9, we're still continuing with inferential statistics. In Chapter 8, we were estimating a value for the mean, mu. In Chapter 9, what we're going to be doing is we are starting with a value for the mean, and we're going to either challenge that claim that the mean is that value, or we're going to accept that claim. So, whereas before in Chapter 8, we were making a claim that our mean was between two values. In Chapter 9, we're either going to say, yes, we think the mean is the value you're giving us, or we think it's bigger, or we think it's smaller, or we just think it's different from what you've given us. So we're going to be given a value, and we're going to be responding in the affirmative or in the negative. We like that mu, we don't think that mu is correct. One of those two. So our first estimate, our null hypothesis, is going to be given by H0. This is going to be our initial claim for what the mean is. So it's often a historical value or production specification, what it should be, and then we look at the actual data from a sample to either challenge or confirm it. So let's look at some particular examples. So in example 1, if the average height of a professional male basketball player was 6.5 feet 10 years ago, we might use the null hypothesis that mu is 6.5 feet for a study involving average height for this year's professional male basketball players. If television networks claim the average length of time devoted to commercials in a 60-minute program is 12 minutes, we would use that average, the mean, is 12 minutes as our null hypothesis, if we are studying the average length of time devoted to commercials. Finally, our third example, if a repair shop claims that it should take an average of 25 minutes to install a new muffler in a passenger automobile, we would use that the null hypothesis H0, that the mean u is 25 minutes. Okay. So here we have different examples. We have historical data used as our null hypothesis in example 1. We have in example 2 sort of a production specification. That's a claim. They look back at what they've done. And in the third one, that it should take an average of 25 minutes. So these are each different claims that the mean is a particular value. So that's what we would use as our initial value for the mean. So any hypothesis, point 2, that differs from the null hypothesis is called an alternate hypothesis. We call that H1. If we get strong enough evidence, then we will accept H1, our new value, and we reject H0. So let's look at example 1. So if we believe that the average height of professional male players is actually taller than it was 10 years ago, our alternative hypothesis that we are testing would be that the mean mu is greater than 6.5 feet. So our H0, our initial hypothesis, would be that the mean is 6.5 feet. But if we don't think that's the case, we would challenge it with H1, that mu is greater than 6.5 feet. So let's look at an example and see if we can determine what our initial H0 would be and our alternative hypothesis H1. So a car manufacturer advertises that its new subcompact models get 47 miles per gallon. Let mu be the mean of the mileage distribution for these cars. You assume that the manufacturer will not underrate the car, but you suspect that the mileage might be overrated. So what are we going to use for our null hypothesis? In this case, we'll use the claim. We'll use the claim that the manufacturer is making that the mean is 47 miles per gallon. What are we going to claim as our alternative hypothesis for H1? Well, it says here in the last sentence, you assume the manufacturer will not underrate the car. This is a very strong selling point, that it has good gas mileage. We don't think that the manufacturer thinks that it's actually 50 miles per gallon and is only selling it as 47. But you think, on the other hand, you suspect the mileage might be overrated. So maybe it's not that efficient. So maybe it's less. So you think that the miles per gallon is less than 47. Okay. So the manufacturer's claim is what we use for H naught. And in this case, that you believe that the average is too high, so you make it less. That your alternative hypothesis is that the mean is actually less than 47 miles per gallon. So when we're constructing our alternative hypothesis, we have three options. We have our null hypothesis, which is our initial claim. It gives that the mean is a particular value. So let's just say k. Our alternative hypothesis, there are three kinds. You could claim that the mean is less than k, you could claim that the mean is greater than k, or you could make the claim simply that the mean is not k. So if you're given a particular value, then you have three options. It's either less than, or greater than, or just different from. So we have different kinds of tests here that we will use. We use a one-tailed test. If you have less than or greater than, these are both one-tailed tests. And we will get into that. And you can use one end of your normal curve to test those. If you are looking at a value which is just different from k, you're going to be using a two-tailed test, and you look at both tails of your normal distribution. This p-value that is referenced here is just a way of saying probability. We will get into the relationship between the tail test and the normal curve in our examples. So let's see what our steps are going to be when we're given a question that involves these hypothesis testing. So our inferences are now about hypothesis testing. So we have to set up what we think our null hypothesis is. Our first step is to establish our null hypothesis, H naught. And then, given the context of the problem, we establish our H1, our alternate hypothesis, which claims that the value of mu is either greater than, less than, or different from. So in the first step, I see that we might be making a claim about the mean, p, proportion, or sigma, the standard deviation. We're going to focus on just the mean. After we have our null hypothesis and our alternative hypothesis, we're going to be taking a simple random sample from the population, and then we'll figure out what our x bar would be. If we're testing the mean, we would take the sample mean. If we were actually interested in either the proportion p or the standard deviation sigma, we would find the proportion or the standard deviation of the sample. If we're interested in mu, we would look at our particular sample and take its mean. Then similarly to section 8.2, we may have to decide to use t instead of z. And we say, what is the probability of actually getting this particular x bar value, which will be our probability. So that is the p-value. We look at our sample, we take its mean, its x bar, and we say, what is the chance that we would actually get that x bar, that mean, that sample mean, if the null hypothesis is true? If there's a very small chance of getting that X bar, then it may be that H naught, our null hypothesis, is wrong. So step 5 is we see how small that probability is, our p-value, and we compare that to what we decided beforehand is going to be our threshold. If there's less than 10% chance that it happens, we think that it's not going to happen by chance. It must be that our null hypothesis is wrong. So ultimately, the answer to a question for us in the hypothesis testing is either we are going to fail to reject our H naught, or we will reject our H naught. Either way, we're not confirming what the actual value of the mean is. We're either saying we have enough information, we have a strong enough information to say that we think it's wrong, or we don't have enough information, so we're going to stick with our H naught. This seems a little theoretical, so keep this in mind. Look at the example either from the Khan Academy or the next one from this set of slides, and I think with repeated examples, this abstract structure will become a little bit more clear.